Yeah, listen.
Okay, good. Let's kick off this safari. Welcome all. Good day, people from all over the world. I think good to see. Welcome to this first safari of organized by USPI this year. We do this typically every year, a couple of them, and we try to come up with interesting topics where we can share experiences and learnings and help to build this kind of community and understanding of each other's activities. So I hope everybody can see my screen. The session will be recorded. That means we will record the presentation by Paul Turner, and after that, with the Q&A, we will switch off the recording so people can be free to ask what you want to ask or discuss.
Is that okay? You can come here, Mama.
Sorry,
we can sit together here.
Yeah, can
I'm not
everybody
talking.
go? Can everybody go on mute, please? Yeah. I'm very happy that we have Paul Turner here with us, going to present the topic today regarding the use of 3D models in commissioning, and I think a little bit broader perspective on data overall. Paul has started his career in the aerospace industry, building too much complex stuff for me, satellites and rockets, very good. And of course, in that industry, there is high quality standards. And later, Paul took that experience and knowledge to other industries like power and wastewater treatment. And based on the difference in quality he observed, I think if I phrase that correct, Paul, that you can do that, say that even better. But as of that lack of knowledge and maybe the gaps in quality, you really worked to found this body called the Industrial Commissioning Association that aims for helping project professionals to understand the complex aspects of commissioning in projects, especially in the large capital projects. So for everybody who has an interest to learn more about that, you could go to the web to www.ICxA.net. You can find way more. You can become member of whatsoever. What you want, a lot of good information there. What I will do now is hand over to Paul. Paul, I want to do one thing, because there are probably a couple of people here that don't know USPI, and let me talk a little bit about USPI for now. So there is a mission, and where we really look into developing and maintaining the use of international standards, best practices for product and plant lifecycle information management. So aiming really to improve interoperability across the whole supply chain, making sure we eliminate necessary cost and waste, and actually contribute to better execution of projects. That's actually the reason why we also invited Paul to come over here, because the first phase, I think, where everything comes together is commissioning before you can even start up. So if you don't have your ducks in a row there, it's going to be a very difficult story, I think. So the intent here of USPI and the ICxA is really to make sure the people are equipped with the right tools and data to do their work. What we do as USPI this year, I think very short. We have 4 main projects that we execute. One is the facility lifecycle 3D management standard, where we are delivering a standard for 3D modeling in projects and how to use that into operations. That's a key element of that standard. We have last year delivered 1.2 of that standard. This year we will deliver the 1.3 scope and do a number of other elements to it, helping the EPCs to ensure the owner-operator specify their requirements correctly. And we will look into 3D catalog management. What we also do as a project is tagging, where we will deliver a tagging philosophy, an initial release, I think that is, and then later, subsequent years, hopefully more in depth. And then we do quite some work on the ISO standard. So 2 main standards here, 15926, which is really around data integration, and there will be some parts of that standard will be updated with an ontology base. We will update the reference data, which is used also by other standards, and we will develop validation rules for the reference data. And we are in the process of getting published the ISO 18136 for nuclear digital ecosystems. And last but not least, we have the information management in large capital facilities, which is really a sharing of lots of good lessons learned over the past years, and where we will come up with some guidelines around how to build a common data environment. And that's a more a learning kind of activity, but we document what we are doing, and that goes by 2 or by a multiple workshop series. We will finalize workshop series 1 this year, and we will start number 2 as well. And last but not least, we do these kind of safaris. So this one is planned, as you can see, for today, the use of benefits of 3D models in commissioning. And next month we will have another one, which is construction work management, a different approach for advanced work packaging by Sarah Belgin, which is on the 13th of March. So if you want to see more of that information, you can find it on our website, www.usp.nl. And just to give you a little bit of background, who are our members? I think most of you will recognize all the, or most of the labels that you see here. So it's really, we are originally a Dutch organization, but we have gone more international, and we really have a mix of owner-operators, EPCs, software vendors, and service companies. So having said all this, you have a bit of background about USPI. You know our speaker, Paul Turner. Paul, again, welcome, and please, the floor is yours. I suggest you drive your presentation yourself and share your screen.
Thanks, Hugo. Thanks for that introduction. Yes, I'll share my screen here. Okay, can you see my screen correctly? Audio is all good?
Yes, I can see, yes.
Okay, great. Let's get started. So thanks everyone for joining today. My name is Paul Turner, as Hugo mentioned, and I'm the president and CEO of the Industrial Commissioning Association. So Hugo gave a good introduction already, so I'll maybe go through these slides a little bit quicker, but I've worked on some pretty cool projects over the last 25 years in the aerospace industry, where quality, of course, is a very important factor, but I just wasn't seeing the same level of quality on some of our ground-based projects. I was working in the power industry, wastewater treatment plant industry, and there seemed to be too much reliance on the reset switch for commissioning, or kind of pushing issues later in projects, where that can't be the case in aerospace, right? Once you launch the rocket, the satellite, it must work in space. So it was it was a little disappointing to see kind of that kick the can down the road perspective with commissioning. And like Hugo said, that's what's prompted me to create the Industrial Commissioning Association to help people understand this complex process of commissioning and ensure that quality is a primary factor on projects. So why is commissioning important? Too often commissioning is just thought of as testing at the end of the project, right? I'm sure you've heard that, or maybe you've seen people that have had that thought process before, is we'll just test everything at the end. And in this presentation, I'm going to show you how commissioning is really the digital thread that connects all the data that we have, this data-rich 3D model environment, and how that's connected with our asset management systems needed once projects are completed for ongoing operation and maintenance of our facilities. Commissioning is really a vital project management process that ensures that we're delivering high reliable systems at the end of projects that meet reliability and meet performance requirements and meet the original intended design intent of the projects. And without proper commissioning processes, there's always costly system failures or unplanned outages that affect projects through normal operations. And traditional commissioning methods, they've often just been lacking to take advantage of this data-rich environment that we have from some of the engineering tools we're using for 3D modeling and leveraging this data on projects through commissioning. Because there's lots of pieces of the puzzle that make up, when it comes to commissioning, that make up projects, and this all must fit together at the end. And the real reason projects are often delayed is because right from the start there was no understanding of how all the commissioning puzzle pieces were going to fit together at the end, and there was no digital alignment or process to make sure that everything functions correctly in the end. Projects always have a lot of moving parts, and a proactive approach to commissioning is required to make sure all the pieces come together and fit together properly in the end. And without a proactive approach to commissioning, projects are late 9 times out of 10. And this is the real reason that a lot of projects are late. The problem with traditional commissioning is projects often result in scattered data that makes tracking of all the moving pieces very difficult. Many teams still rely on inefficient data processes, increasing the risk of lost information or inefficiencies, or are still maybe even using paper processes and Excel processes, and that just doesn't cut it for complex projects anymore. A lack of streamlined data makes it very difficult to manage information on a daily basis. The fundamental problem is that a lot of organizations only focus on what they can see, right? You can see people in the field doing the on-site testing and physical interaction with the equipment as the tests are taking place. And they think that testing is the bulk of the effort for commissioning, but testing is just the tip of the iceberg. On-site testing is only 20% of the commissioning process. And with all the risk mitigating activities that need to be done to have successful testing later, that's hidden below the surface that a lot of organizations don't necessarily see. And that part of the commissioning process often gets forgotten about. When organizations only focus on on-site testing, they're missing 80% of the activities for a robust commissioning process. This is the 80% of risk mitigating activities for commissioning that ensure that your on-site testing at the end of the project actually goes smoothly. These 80% of activities, these are the steps of the commissioning process that are hidden below the surface if we're using this iceberg analogy. And these are what makes sure your on-site testings are actually successful. And if you're only focusing on the tip of the iceberg and focusing only on testing, then you're adding a lot of unnecessary risks to your projects. This outdated construction-led approach to projects is what leads to 9 out of 10 projects being late and over budget. A better approach is to take advantage of the data-rich environment that exists on projects and use this data to our advantage to manage commissioning and manage the ends of our projects. There are vast amounts of data on projects that is being unused, and not being gathered to make quality decisions on projects, because the quality of your data, it directly impacts the quality of the decisions that you can make on projects. 3D modeling facilitates the bridge between this data-rich engineering environment and operations by implementing a robust commissioning process to connect those two critical aspects of projects. And these data-rich 3D model environments must be leveraged for improved project commissioning to ensure data consistency and eliminate gaps between design and implementation. 3D modeling has evolved significantly over the years. It was initially used for design validation and class detection in the 90s, and it's now an essential tool for commissioning, ensuring that no elements are overlooked. The project definition and data generated from 3D models during our engineering and detailed design phases is essential to defining a structured commissioning process as well, to define the systems-based approach for construction completions and on-site commissioning workflows, and to define the methodical approach in how projects meet cost and schedule objectives. Not only are 3D models created in BIM 360 type of environments for engineering design activities, but these data-rich environments are used to define our construction completions and our commissioning workflows for a smooth transition from construction to commissioning, integrating the beginning of projects to the end of the project for a complete digital thread through all phases of the project. So traditionally on projects, construction groups focus on area-based construction, and rightly so, to optimize long lead deliverables and coordinate large workforces and optimize installations by area. At about 60% or 70% through construction, installations must transition to systems-based completions. And this is where the power of 3D modeling is used to ensure a smooth transition from construction to commissioning. And with a robust definition in 3D models of each system handover, nothing gets missed, and all project groups are aware of responsibilities to complete each work and complete each milestone of our gated commissioning workflows. A structured systematization approach in 3D models ensures a smooth handover process, reducing risks and improving project efficiency. And as I'm sure you're aware, the last 10% of any task to get to completion is always the hardest, right? How many times have you seen someone start a task, but it's difficult to get to completion, right? That last 5% or 10% is always the hardest part of every task. It happens to all of us, and construction and commissioning is no different. But by leveraging a system definition in 3D modeling software, this helps all project stakeholders understand what is actually required to complete the work at each gated milestone, making the last 10% of all tasks much easier for everyone on the project to actually achieve by large teams that we need to coordinate to complete the work. One thing we notice on projects is everyone's definition of complete seems to mean something different, right? I'm sure you've seen it on your projects that complete to the construction folks means something different than complete to the commissioning folks. And that's where a lot of the discussions end up taking place, is what does complete or what does done actually mean? When every piece of equipment is tagged in our 3D modeling software with a complete system definition and all associated project documentation requirements, there is no ambiguity on what complete actually means in projects. And all project groups, regardless if they're from design, construction, commissioning, everyone has a clear definition of what needs to be done to actually achieve completion of each handover milestone, from every big piece of the project down to every little setting in a VFD. Everything's defined so that nothing gets missed. And with that approach, then expensive delays are avoided by avoiding surprises when things are missing. when we have this data-rich 3D model environment, what data is actually being managed? It's more than just a pretty 3D representation of your project. I'm sure you've seen the wireframe models, but this is a lot more than that. I'm sure you've heard of the term digital twin, and when used properly, a complete digital representation of your project is created in software to essentially simulate your project environment. And this opens up a whole bunch of possibilities when a high fidelity digital twin of your project is created with all the associated data to fully define project functionality and operability. 3D modeling software manages more than just documents. Everybody's got a document management system on their projects where all the PDF files are uploaded. We're talking about more than just document data. This is actual project data and the specific details and functionality of each of the project components and system definitions. It creates a comprehensive digital representation of all project systems, a digital representation of your project that actually functions, not just an image of your project, like the 3D wireframes that you've maybe seen. These are actually functioning projects where you can test the function and performance of particular systems in software before even building them in the field. This gives you high quality tracking and management of equipment and data where you can actually verify some of these systems before testing in the field. And this reduces risk significantly later during real world operation so that you can prove the project design rather than having to wait until on-site testing begins. A lot of projects we look at, they suffer from a lot of the phases of projects end up being very siloed. The engineering team designs, they create design packages and they toss them over the wall to the construction folks, and then the construction folks do their good work installing their equipment, and then they pass the pieces to commissioning folks to have to integrate everything together. But this is hardly an efficient approach to projects by having each group complete tasks in isolation. A better approach is to start with fully developed 3D models and ensure the digital thread keeps data connected across the entire project lifecycle, ensuring accountability, traceability, and efficiency through all stages of the project. And your 3D model becomes your single source of truth to define the data needed through all stages of projects. With a robust data set, nothing gets lost through system handovers, ensuring traceability and accountability at every stage. So there are some groups that are really pushing the boundaries and developing high advanced technologies with digital twins, and they're using them as essentially a virtual environment to test system performance before a single installation takes place in the field. The term sometimes referred to as virtual commissioning, and this allows teams to test and verify system functionality before field deployment, reducing any of the challenges with integration or unexpected issues that come later during on-site testing. And this reduces risks and saves time because commissioning at the end of your project is the critical path to get to your in-service date. Any disruption to that critical path is very expensive, and we want to avoid that. By taking this approach and verifying system functionality in advance, we can prove the systems function and that their system readiness and pre-startup conditions are in fact what we need for startup, and that's going to make our startup go much smoother. On a project where we simulated the control systems, it was an HVDC project, and we simulated all the control systems in a very high fidelity environment with digital simulators. When we got to on-site commissioning, we were essentially only looking for wiring errors in the field because we had already proven that the 60 control and protection cubicles to manage this system, that everything functioned as intended and functioned as it needed to before we even delivered those cubicles to site. So when the cubicles were wired on site, there was a few minor little wiring errors, but we knew that that system worked. And startup, in fact, took place flawlessly and effortlessly because we knew everything had already been proven in advance in a digital environment. So we had a smooth and safe startup on site because we had already started the system several times 18 months prior and knew that it was going to function. 3D models create this great training opportunity as well, where we can use these systems to train our plant operators, have them familiar with these complex systems so that they're ready for startup and handover of the systems at the end of the projects. And for complex systems, this is paramount that operators are familiar with safe and efficient operation of the facilities, especially when we're working on infrastructure that is dependent on in society. We can't be starting up these systems and having unplanned outages. They need to work with a high degree of reliability, and we can prepare operators for that environment using 3D models, digital simulators, and the systems used from verification of control systems to prepare operators. So we provided a digital environment of the plant HMI to operators 6 months in advance and had each operator perform all of the system SOPs in a simulated environment in advance where there was zero risk that they could do any damage as they're learning or understanding the systems, and become very familiar with plant operations ready for startup. And when it came time for startup, each operator had already started up the system several times on the simulator. So they were very familiar with the startup sequences, including all the contingencies that needed to be considered for any of the plant failure modes, if something were to go wrong during startup. So training in 3D environments helps our plant operators familiarize themselves with the systems, which improved performance and saved time during on-site activities, as well as reduced operational risks as the facilities were placed into service. With a centralized digital model, teams can collaborate much more efficiently because data is easier to get access to. Often on today's projects, it's challenging just to get the right document and get the right information. And when there's those barriers that exist in information flow, that slows the project down quite a bit. But when you have these digital systems with all the information in one location, then this reduces misunderstandings and helps all project groups understand the complexities of commissioning. And anything we can do to foster easier access to information and easier communication on projects will always contribute to smoother project execution. So some additional benefits of 3D modeling on projects and some of these high quality data environments that we use for a robust commissioning process are improved traceability. If there's a supplier that has an issue with a piece of equipment, then it's easy to trace exactly where that item is installed. And this was very important in my aerospace days. If there was even just the tiniest little screw that had an issue, we knew exactly where that item was installed everywhere on a rocket or spacecraft system. And the same issues can happen on large projects spread out over a large area. If there's a potential issue with a piece of equipment, no matter how big or small that is, we need to know on the project where those items are installed so we can address potential issues. Improved efficiency, which with easier access to information, where instead of looking for information, the information is pushed to each person. So you no longer have to go looking for what you need. The information is pushed to you, that it's at your fingertips and easy to access and no longer difficult to find. And improved risk reduction. This is probably the biggest benefit, where risks are identified and mitigated much earlier, ensuring a streamlined commissioning process to avoid expensive delays. And this was my biggest issue that I saw from aerospace to ground-based projects, is there was always I wouldn't say a desire, but it always was easy to kick the can down the road and push issues later in projects. But by taking a proactive approach in our 3D models much earlier in projects, we can prove out some of these systems and reduce risks on projects so that they don't become expensive delays later. As systems become more powerful, I think we're only starting to see the capability of AI to manage data on projects. As AI is incorporated more into the commissioning and our project workflows, these systems have the ability to analyze huge data sets and give us insights into predictive analytics that we've just never had access to before. And large projects are, I think, really a best use case for AI to analyze these huge data volumes, large data sets, and give us more insight than we've had available to us on past projects. As these large data sets, as we're gathering this information on projects, then the data sets become quite large. It's more than just your PDF documents of the documents on your project. This is the actual data that's recorded and managed on a project, as in how long is it taking to do particular loop checks, what are the bottlenecks, what are the workflow efficiencies, and getting these insights that we've never had before to manage some of this data in real time and make real-time decisions. Because as you know, the cost of delays increases as projects progress, right? While the cost of commissioning is typically estimated, the number is usually about 5% plus or minus a little bit of the overall project budget. When it comes to the critical path of commissioning at the end of projects, the cost of delays during commissioning can become astronomical in the millions of dollars per day. I've worked on projects that have a $5 or $6 million daily burn rate. And when you're faced with those kind of numbers, every day of commissioning is valuable, and we need to be doing anything that we can earlier in the projects to protect any delays during commissioning. So it's typically money well invested early in projects to avoid these costly mistakes later. And that upfront investment in commissioning and implementation of mature 3D modeling processes following the best practices that we've outlined in the ICxA Global Commissioning Standard, this is an excellent investment and ROI to protect projects from ending badly. Robust commissioning processes, as defined in the ICxA Global Commissioning Standard, are essentially your digital thread to connect data-rich 3D modeling environments at the beginning of projects to your asset management systems needed for operation and maintenance at the end of projects. This digital thread is imperative on today's projects, since operation of industrial facilities is a complex process in itself. And when it comes to regulatory compliance or operational efficiency, or just daily routine maintenance to troubleshoot and fix systems to maintain performance, too often on projects we see this 3D modeling data-rich environment, but then fall apart with a lack of robust commissioning processes, but then still the expectation to come out at the end of the project with all the data rich and products from the project needed for operations. And without that robust commissioning process in between those two processes on projects, then things kind of fall apart. When commissioning processes are digitalized per the ICxA Global Commissioning Standard, the digital thread is maintained through all phases of projects for a continued data-rich environment in operational phases, so that nothing gets lost and automation is put to good use to prevent human error and improve data integrity. Now, despite all the benefits of 3D modeling and data analytics on projects, digitalizing the commissioning process, there are several still common barriers to adoption of these systems on projects. These systems are often viewed as high cost to implement, rather than viewed as the opportunity for long-term savings. The construction industry, unfortunately, suffers from the way it's always been done and is sometimes reluctant to adopt new ways to do the work. And many project teams feel that they don't have the skill sets to implement these specialized systems, or if they sometimes project management feels that if they train their people, then they will eventually just leave to another project, taking all their expertise with them. And it can also be challenging to integrate new ways to work into existing workflows. To overcome some of these data integration challenges, it does take strong leadership to see the big picture and guide the team on new processes and maintain that digital thread. It does require a visionary leader to challenge teams towards excellence, but the results pay for themselves for the courageous leaders who can effectively implement positive change for their project teams. There is no denying that all industries are evolving. The information age that's been upon us for the last couple of decades, the AI revolution that's a bit more recent, all industries are evolving, and the construction commissioning industry is no different. The pace of change is rapidly increasing now that you hear everything in the media about AI, and it's hard to even fathom or keep up with the pace of change these days. Where will the industry be in 5 years from now? I'm not sure anyone can predict that, but one thing is clear is that the project teams that refuse to adopt these new systems to do the work are quickly going to get left behind because the more progressive project leaders are going to leverage these new technologies for improved project success. And the pace of change is just increasing so quickly that others will quickly get left behind. So no longer will manual processes be appropriate to define projects and manage data on our projects. The younger generation is coming to projects with their phone in hand, and they're expecting modern methods to help them complete their work. And with the competitive landscape for experienced labor, they'll just go down the street to more progressive organizations that are adopting better ways to work. So while some project teams have been able to avoid the digital transformation for the last couple of decades and continue with manual work processes, there is more of a necessity for digital transformation than ever before, given the increased pace of technological change on projects. And personally, I can't envision a company in 5 years from now that is still using manual methods to manage data on projects. They just won't exist, since the more progressive companies will drive the others out of business as we harness the AI data revolution that is upon us. So if there is one thing you take out of this presentation, is that commissioning is a data-driven process and is the digital thread connecting all phases of projects. And if you're still of the mindset that commissioning is just testing at the end, then you're missing a significant opportunity to completely revolutionize your project delivery for improved cost and schedule performance. And the companies that embrace the use of data on projects will be the leaders in the industry in 5 years from now. Begin your projects with robust 3D models in a data-rich environment and leverage the data through all stages of projects to complete your digital thread. Leverage AI and predictive analytics for future efficiency and embrace digitalization to stay competitive. So I want to share a case study with you that embraced the digital environment with a full fidelity simulation of complex HVDC stability controls in a 3D environment. So it was very interesting because these two HVDC projects were taking place at the same time here in Canada. The first one was Bipole 3 power project in central Canada. I was the commissioning manager on this project, and we implemented a full fidelity simulated environment of the project control systems 2 years prior to the in-service date. That testing took approximately 6 months in the factory, and we fully tested all normal operating modes and all contingency operating modes so that we could verify full functionality of the system before even shipping any of that equipment to site. And we had full confidence that the system worked before we even started on-site testing. While we were working on the Bipole 3 project, there was a similar power project taking place on the east coast of Canada called Muskrat Falls. Now, they took a different approach and they did not test their systems in a 3D simulated environment in the factory to verify the project functionality. And this is reflected by the fact that the project had significant difficulty achieving full power transfers. And in fact, the project was 3 years late due to a lot of the software problems that they had because they didn't prove these systems out much earlier. Both of these projects were multi-billion-dollar HVDC transmission projects, and it was interesting because they were very similar happening at the same time, and we could compare the different approaches that management was taking for commissioning and digital verification and the use of data in simulated environment to manage risk. We completed the Bipole 3 project on time and on budget, while the Muskrat Falls project was unfortunately 3 years late, millions or maybe even billions of dollars over budget. And in fact, it resulted in a public inquiry that, if you're interested, you can read at muskratfallsinquiry.ca if you want to check it out. So the benefits of 3D modeling and high quality data used early in projects, it was clear to me after seeing the comparisons between these two projects. So we've covered a lot of good information in this presentation, but what's next? How do you actually make use of 3D modeling and the data generated from such high fidelity systems? If you implemented the systems and processes we've discussed today, do you think you would be able to make better decisions on projects, having access to better models, better information, better data? Do you think you'd be able to leverage this data to reduce risk and improve the quality of projects? And do you think you'd be able to deliver projects more efficiently with access to these tools and data to meet cost and schedule objectives on your projects? There are actually only over 25 different commissioning software systems on the market that leverage the data from 3D modeling systems to connect the digital thread on projects through all stages. Now, none of these software systems are ours. We don't make software, but we do use the good systems here on our projects to manage commissioning. And you can get this list and a review case studies of each of these software systems when you log into the members area of the Industrial Commissioning Association. We've got case studies, client reviews, and reviews of a lot of the leading software systems that are needed to manage commissioning data. Some of these are better than others, and some of them are better suited to specific industries, and you can get all the case studies and customer reviews if you're interested in the members area to help you choose the right ones for your projects. So it's a choice that project teams can make, right, to embrace 3D modeling data on projects and use these tools to your advantage for improved project performance. You can choose one path to stay essentially where you are and ignore the data revolution that is upon us, or you can take the other path and embrace impactful and positive change and leverage the tools available to your advantage. And the choice, of course, is each project teams to make to see how they want to progress on their projects and take advantage of these data-rich environments. So that's the end of my presentation, and thanks for joining. I certainly appreciate your interest in commissioning and the use of 3D modeling data on projects. I'm available to take any questions, and if you'd like to get in touch, you can learn more about the Industrial Commissioning Association at ICxA.net, or feel free to shoot me an email at info@ICxA.net. Connect with me on LinkedIn. If you go on LinkedIn and search for Paul Turner Commissioning, you'll find me there, and I'd be happy to connect with you. Thanks for listening. Back to you, Hugo.
Thanks, Paul. Thanks a lot for all this in-depth information. Very, very good. Vincent, can I request you to shut off the recording so people are more hopefully to have some questions and maybe some
I will stop the recording. Yeah, sure.
Yeah.
I'll stop the recording right now.
Thank you.